Yeah, a very good morning, everyone. Welcome to IT365 session. So where we are discussing about protocols and IP addresses. Okay. So first we're going to see the different protocols in OSI protocol stack, and so then we shall jump into the IP addresses. So IP address is very important to identify a system in the network. So we know that we got lakhs together systems in the internet, and when I send a message to you, okay, so how exactly the router or the networking devices finds your system to deliver the message. So that is through IP addresses. Along with IP address, we got MAC address as well. So those things we're going to discuss. And before that, so let us quickly recall. So what is what topics we covered in the previous session? And in the previous session, we have seen what do you mean by crosstalk. So that was the very first topic what we discussed. The crosstalk is nothing but a signal in one channel interfering or disturbing signals in another channel. So in the last class, I hope you remember that. So we have seen one diagram where we had two different channels, right? And this is channel one, and this is channel two, and signals used to transmit like this. Okay, so this is sender and this is receiver, and this is sender one and receiver one. So and data used to go like this. And so whenever, okay, so no this crosstalk happens. And before that, why crosstalk happens? So because of some EMI, okay, so electromagnetic interferences. So because of some EMI, okay, so we just assume that this is a EMI input, and because of this EMI, the signals in channel 2 so can disturb signals in channel 1. So in that case, so here the receiver will not receive the expected signal, so it will be noisy. Okay, so we call it as signal noise ratio, SNR. So SNR will be very high. Okay, so SNR will be very high. So this is called as crosstalk. So this EMI, so why this EMI? So again, the question comes. So it can be intentional or it can be unintentional. So intentional as in, so there are some, supposing that there is an intruder and the intruder wants to disturb the communication. So in such cases also, the crosstalk appears. In some other cases, because of you're passing through high power lines or you're passing through, talking about wireless medium. So if you are passing through, oven very close to, if you go very close to oven, so these are all some of the examples. So where EMI can interfere in your communication. And apart from that, we have seen different networking devices. So we started with routers and then bridges. The routers are basically connects two different networks. Bridges also connects two different networks. Only difference is it basically different protocols. If within the organization, okay, so within the organization, if multiple networks are there, so then bridges comes into picture. So at last, routers should be connected there. Okay, and in at a low level, I can say, okay, at low level you can use bridges when you want to connect two different networks. And we have seen switches. Switches basically creates LAN, right? And switch has got a individual access to each and every system in the LAN. That means switch knows the MAC address as well as IP address of each and every systems in the LAN. And we have also seen that switch is intelligent, right? So why? Because it supports unicast, multicast as well as broadcast. Okay, so unicast, multicast as well as broadcast. So also it provides a little bit of security, and so it has got a store and forward capacity and all those things. So compared to hub, switch is intelligent, as I said. So hub is less intelligent, that's what we call. So hub is also used to connect different systems in LAN. So that means visibility of hub and switch is at LAN, local area network level. And only difference between hub and switch is in hub, it supports only broadcast, whereas in switch it supports all other kinds of medium, I mean communication. So then we have seen repeaters. Repeaters are nothing but, so when you're propagating signals for a longer um, geographical area, there are chances like your signal may get weak, okay, after some after some time. Okay, so that is why, so at regular intervals, okay, not intervals, at regular distance, these repeaters have to be placed so that it receives the weak signal and it regenerates the same signal. Okay, so it's a strong signal basically, which can propagate uh, for further more distance. And then we have seen gateways. So as the name itself indicates, it acts as a gate, right? It acts as a gate for incoming as well as outgoing packets. And then we have seen Ethernet cards. Ethernet cards basically, it's through this only we are connecting to the internet. And so we have seen OSI and TCP/IP protocol stack, where different layers as well as their functionalities being highlighted. And so coming to today's class, so just see this one. So this is the classical OSI protocol stack, what we have seen. And so let us see how information flows from application layer to physical layer. So this is the most common question what we ask. Okay, so this is the most common question what we ask in the exam as well as in the interview. So how information flows from application layer to the physical layer. So at application layer, okay, so information is, either it is called as data or information, and at the presentation layer also it's called as data or information, as well as at session layer. But once this information passes the session layer, what do you call, we are going to make it smaller. Okay, so because as it is the entire information, supposing that, so I'm sending a message. Okay, so we are listening to IT365 session. So this entire message cannot be sent as it is because it's quite big. Okay, so for that reason, so we're going to split it up into different chunks of data, and those chunks of data, so we're going to deal from transport layer. In transport layer, this information is divided into segments. Okay, so in transport layer, so these information or data is divided into segments, and these segments are transmit or transferred to the network layer, where so these segments are further, okay, so further converted into packets, or it's a smaller version of segments. And when these packets are transmitted from network layer to data link layer, it will be further converted into frames by data link layer. And once these frames are transmitted to the physical layer, its physical layer will transmit these frames in terms of bits. Okay, so because at last, so what over the medium, so we should transmit everything in terms of zeros and ones. So bits means zeros and ones, right? Zeros and ones. So here at physical layer, though we got a frames at data link layer, so frames will be received by physical layer, but it will transmit these frames in terms of zeros and ones. So this is how information is transmitted, so from application layer to the physical layer. So this is at the sender side basically. Okay, so at sender side, information will be transmitted from application layer to the physical layer, right? Application layer to the physical layer. Whereas at this receiver side, the same process will be repeated. So what happens? So receiver will receive. Okay, so receiver will receive zeros and ones first, right? Zeros and ones. So that is at the physical layer. So once zeros and ones is received, the frames will be formed up at data link layer, and at network layer packets will be formed up, right? And at transport layer segments will be formed up, and so then from session layer, so it will be converted into data or info, right? Hope you got my point. So this is at the receiver side, and this is at the sender side. At the sender side, information will be transmitted from application layer to the physical layer. So whereas at the receiver side, information will flow from physical layer to the application layer. Okay, so like this. So at the receiver side, so zeros and ones will be converted into frames. The frames will be converted into packets. Packets will be converted into segments. And again, Okay, so the actual information will be given to the receiver. Okay, so like this. So this is how information passes from application layer to the physical layer in OSI protocol stack. So in the last class, I told you that the OSI protocol stack is no longer used in any application, but still, for all the theoretical knowledge, theoretical study, we still refer OSI protocol stack only. Okay. And so TCP/IP protocol stack. If you study OSI protocol stack, by default, you're studying TCP/IP protocol stack as well, right? So that is the concept here. That's one. And so that's about information flow from source to destination. And coming to the different protocols which are available. Okay, so in OSI protocol stack, so let us go one. Let us take layers one by one, and let us discuss that. In case of application layer, we got HTTP protocol, file transfer protocol, telnet, and domain naming service. So all, a bunch of protocols are there in application layer just to make sure the user will get a proper quality of service as well as proper quality of experience. Okay, the most number of protocols you can find in application layer only. Okay, so then the presentation layer comes, and in the presentation layer we got lightweight presentation protocols, we call it as LPP. Okay, so basically in presentation layer the security part comes. Okay, security, if anyone asks. Okay, so if you say that I'm working in security, and if anyone asks you like in which layer you're exactly it falls, then immediately you should say that it's a presentation layer. I'm working on presentation layer. So presentation, how? Okay, so how information should be presented, so something like that. And so coming to the session layer, we got you know uh, RPC protocol, remote procedure call protocols. We got SOCs, and we got SCP, secured copy protocol. We call it a secure copy protocol. So, and we got other protocols as well. Just I'm mentioning a few very important one. So coming to the transport layer, so we should mention TCP as well as UDP. So TCP stands for transmission control protocol, and UDP stands for user datagram protocol. Okay, so TCP as well as UDP. So coming to the network layer, so we got different routing protocols. A lot of routing protocols are available till today. People are, even today people are working on routing protocols just to make sure. So how fast? So your call should get connected to the other system, and so how the quality of the call and all those things. So we got internet protocol as well, IP, and internet control message protocol, ICMP as well. So we got multiple protocols over here. And coming to the data link layer, so we got address resolution protocol, reverse address resolution protocol, and neighbor discovery protocols, channel access protocols. So we got many protocols over there. Okay, so I'm coming to the physical layer. So we got line coding. Okay, so line coding is technique. So where using which the bits zeros and ones are represented. Hope you remember that one. So zeros and ones, line coding. No, high bit, and for zero we are representing low bit. This is time actually. So this is one and this is zero. This is one of the technique actually what I'm telling. So this is line coding. Okay, so high voltage and low voltage. High voltage represents one and low voltage represents zero. Okay, so like this. So at the receiver side, if high voltage is received, that means it's one. And so low voltage, if low voltage is received, that means zero. So that's how receiver will decode it. There are many line coding techniques. This is the simplest one. So of course, so we got many problems with this one. So these are all different protocols what one can find in OSI protocol stack. And as I said, so very important one I have mentioned over here. So, and apart from this, there are many protocols, recent protocols as well. These are all classical protocols what I'm referring. The recent one is HTTPS, right? That's a recent protocol, just added security over there, like that. Now the question comes, so why we need two addresses to identify a system in the network? So what are all those two addresses? So first one is IP address. Each and every system has got an IP address, right? And second one is each and every system has got MAC address as well, right? So each and every system has got two addresses. So that is the question here. So why we need two addresses to identify a system in the network? You may argue me that so IP address is enough to identify a system. Yes, IP address is enough, but so there are chances, in that case router has to deal with router should have a complete knowledge. Okay, so complete knowledge about local area network as well. So that is, so because already router is overcrowded, overburdened. Over and above that, you are asking router to remember the each and every individual system as well. So probably router will not cope up with the requirement. So that is why, so we are using IP address as well as MAC address for identifying a system. Now say this one, so both are unique identifiers, yes, and still we need both addresses for identifying a system in the network. And you just say this one how. So router uses IP addresses for finding the target network, and switch uses MAC address to find a specific system in the LAN. So this is the target system. Okay, so now say this one. So there are no two networking devices involved in finding a system. One is router and another one is switch. So router identifies a network. Okay, so destination network. Okay, so router identifies a destination network. Okay, so using IP address. Okay, so it uses IP address. Whereas switch, okay, switch identifies an individual system in the LAN local area network using MAC address. So here, so individual system will be identified. Now say this one. What exactly happening here is, okay, so the responsibility is shared. Okay, so responsibility of finding a individual system is shared among router as well as switch. What router will tell us, I'm going to identify the destination network. I'll pass the packets to switch. Now switch will take over those packets and it will identify individual system or destination system, and then it will pass that packet to the destination system. Okay, so switch has got a individual knowledge. I mean, switch has got the complete knowledge about individual system in the local area network. So right from the beginning, I'm stressing that point, right? So switch has got the complete knowledge about individual system in the local area network. That means once the packet reaches the switch, so switch can easily identify to which system this packet has to be transferred, right? So that is the advantage here. Now, so if you use only IP address, then switch part will not come into picture. Then router itself has to deliver complete, router itself has to deliver packets to the end system, destination system. So router might be overloaded in that sense. That is why, so we are dividing the task between two networking devices. One is router, another one is switch. Okay, so now let us see this example. So probably by seeing the example, you'll come to know, you might understand it, better. So let us take on to the classical topology, what we have referred in the previous class. And so here we got different LANs. So this is LAN 1, LAN 2, LAN 3, as well as LAN 4. Okay, so these are all routers. You know that, right? These are all routers. And we got multiple routers here, right? And each and every LAN has got one switch, right? This is the switch. And this one as well, and this one as well. The starting point for any LAN so will be a switch only. Okay, so we got switch, we got routers, we got a couple of systems as well. See this one. Okay, so this is the topology what we are considering now. The each and every local area network or each and every network has got a network address. Okay, so network address, using which that network, that particular network will be identified. So here in local, in this example, so this local area network, that is LAN 1 and LAN 2, for example. LAN 1 is identified by 192.168.1.1. 1.x. Okay, so x doesn't have any value, so only this one, 192.168.1. So this is the network address of LAN 1. Similarly, for LAN 2, the network address is so 201.18.15. Okay, so whenever a packet is sent from this network to this network, so router will identify only source network and destination network. That means 192.168.1 and destination address is so 201.18.15. Okay, so that is the router visibility. That's what I'm telling. So router will find out the destination network. That's it. So for the destination network, packet will be transferred. So now, so once the packet comes over here, the switch will take over, right? So that is the what do you call the working principle over here. So now each and every network has got an IP address. This is the network IP address. So this is the class C IP address. So if it is class B or class A, so if it is class B, first two octets, and class A, the first octet. This is the class C IP address basically. Now see this one. So now, so let us send some data from LAN 1 to LAN 2. So let us see how it goes. Now see this one. So this is the switch what we have, and each and every system has got MAC address as well. So for time being, just I'm giving MAC 1 and MAC 2. So it's a alphanumeric one basically. And now, so this is the source and this is the destination. So source 1 IP address is 192.168.1.1. And remember that. So we're not supposed to say here, we're not supposed to use word point. Okay, 192.168 point. No. So IP address is represented in a dotted decimal format, dotted decimal. That means, so we should read IP address as 192.168.1.1, right? Okay. Now, so this is the source and this is the destination. So 192.168.1.1. So that is system 1. This one is sending a packet or message to 201.18.15.2. So this is the destination address. Now, how exactly it happens? Now, so router will receive that packet. It will extract only the network address now. Okay, so now see what happens. This router will extract only a destination network, network, how it is extracted using subnet masking. Using subnet masking, the network address is extracted by the routers. Now the router will come to know that this router, the destination network is 201.18.15, this one, right? Now, so for this network, it will find out the shortest path and somehow the packets will reach this switch now. So once the packet reaches this switch, the router responsibility is over. Now this switch will take over it. Now, so once the packet reaches the switch has to find out the individual system, right? So the question comes, how switch maintains the individual information, system information. So that is using ARP table. So ARP stands for address resolution protocol, address resolution protocol. So this is the simple example, the table structure what I have shown. So this is the IP address, and for this IP address corresponding MAC address. And we got two systems over here, MAC 1 and MAC 2, MAC 1 and MAC 2, and corresponding IP address. Now switch, as soon as packet comes, it will check out the IP address. The IP address mentioned is 201.18.15.2, right? And it will extract the corresponding MAC address. This is MAC 2, and to this system, the packet will be transmitted. The ARP protocol is used to map the IP address to corresponding MAC addresses. Hope you got my point now. So this is how, so router and switches so go hand in hand to deliver packets. Okay, so from source to the destination network. Now, so a couple of questions. Let us ask questions to ourselves and we shall find out the answer. So can one MAC address have multiple IP addresses? Can one MAC address have multiple IP addresses? The answer is yes. Okay, so you can have multiple IP addresses for a single system. So basically what happens is, so in your system, So you got a single MAC address. That means, so where exactly MAC address will be there? So that is the first question. The MAC address will be there in NIC card, Ethernet card. Okay, so MAC address so will be there in NIC card. Okay, Ethernet card. So an Ethernet card can have multiple IP address. That is the that is the point here. So yes, we can have multiple IP addresses for a single NIC card, but the vice versa. Can one IP address have multiple MAC addresses? The answer is no. Okay, so that means, so a single IP address, two different MAC systems has got same IP address. Then switch will get confused to which system the packet has to be transmitted. So okay, so say this one. So this is two systems. Okay, so this is MAC 1. Okay, and so this is MAC 2, and in ERP table, okay, in ERP table, address resolution protocol, which is maintained, okay, so which is maintained by switch. Okay, so this IP address is, for example, 1.2. So 1.2 as well. So 1.2 MAC 1 and 1.2 MAC 2. Now the question is, can one IP address 1.2, 1.2, 1.2? So can one IP address have multiple MAC addresses? Okay, so 1.2 has got two MAC, pointing to two MAC addresses, MAC 1 as well as MAC 2. Now switch will get confused to which system the packet has to be transmitted, right? So this is not possible. And whether MAC addresses will ever exhaust. So because we have seen that, so V4 addresses, right? IPv4 addresses, or almost like, so there was a, we have seen that we are running short of IPv4 addresses, and that is why we are moving to V6 addresses, right? Right. Now the question comes, just like IPv4 addresses, whether MAC addresses also exhaust? The answer is no, actually. So because IPv4, we got a unique format, and it's a common format across, okay, so across the world. Whereas MAC addresses, we just see this one. So it is vendor specific, basically. It should not, it's a, each company has its own format. It's vendor specific, basically. Okay, so now say this one. I'm vendor, I'm one vendor. I'll start all my MAC addresses with K and something. And you're one more vendor, and you will start all, all MAC addresses with I, say, for example. Okay, I and some MAC addresses. So like this, we got all the probability, like, all possible probability we can use, and using permutation and combination, we can come out with a lot of MAC addresses. It will never exhaust, actually. Okay, so like this. Now, so who gives the internet protocol addresses, IP addresses? If I ask question to you, so with respect to NITK, so you will say that system admin will give or TRIPSI will give. Okay, so it's a norm, it's a pretty straightforward answer. But actually, and who gives the IP address to system admin or TRIPSI? So that we should ask to ourselves now. So there are different authorities. So just say this one. One more. Yeah. So Internet Corporation for Assigned Names and Numbers, ICANN is there. So Internet Assigned Number Authority, IANA is there. Regional Internet Registries is there, RIR. And at last, Internet Service Providers will come into picture. So now, so this, our TRIPSI will get IP addresses from ISPs, and ISPs will get IP addresses from RIR registries, and RIR has got a governing body called as IANA, and IANA has a, above IANA, ICENN. So this sits. Okay, so these are all the governing bodies. Okay, so which decides which IP address should be used where. Okay, so otherwise, so there'll be a total chaos, and all IP addresses will get, mixed, and there'll be a mix and match, and the packet will never get delivered to the destination. For that reason, there should be some governing bodies, and these are all the governing bodies what we got so for deciding the IP address. Now see this example. Again, we got different authorities. So if you go for North America, we got ARIN, so South America LACNIC, and African countries AFRINIC, and all the Asian countries we got Asia Pacific NIC, and we got the Russia and all Middle East and all. So that is covered by RIP. Okay, and so here, so we are here, and all the IP addresses what we get is managed by Asia Pacific Network Information Center. Okay, so now you got a proper answer, I guess. So from where you'll get an IP address? From ISPs, from ISPs, from where they will get it, from APNIC. Okay, like this. Now, so how to manage the IP addresses? Okay, so entire world needs IP addresses, right? Entire world needs IP addresses, and we cannot restrict people. So we cannot say that no, you should not join to internet, right? We cannot restrict people. And at NITK itself, we just take an example. At NITK itself, 500 plus systems are there, and that is excluding hostels. Okay, so that's excluding hostels. So only in departments I'm talking about. So you just imagine IP addresses for 500 systems. Okay, so how to manage? What about the cost for 500 plus IP addresses? That's very costly. And the solution is, so we can go for public and private IP addresses, right? And it increases the IP addresses basically. And so the other option is IPv6. Already people are working on this, but so public and private a combination is working very well. So what do you mean by public and private IP addresses? A private IP address is one which is local to the organization. In NITK also, we are using all private IP addresses, and we got only, okay, so 2 or 3 public IP addresses. Okay, so 2 or 3 public IP address, and remaining all, okay, so we got the private IP address only. All these private IP address, okay, all these private IP addresses are mapped to public IP addresses using corresponding port number. Okay, so the port number plays a vital role in connecting these private IP addresses as well as public IP addresses. Okay, so this is how. So as I said, so we got around 500 systems, 500 plus systems. For all those 500 plus systems, we can use private IP addresses. The best part is we don't need to pay for it. All those 500 plus system IP addresses. Only for 3 public IP addresses we need to pay. That's it. Okay, so now imagine how much money we are saving, as well as how much IP addresses we are saving at the in the real world. Okay, so if imagine if private IP addresses address was not there, then we would have purchased nearly 500 plus IP addresses, would have paid as much amount, and 500 plus IP addresses would have been blocked by us. So that is the, so now only 3 public IP addresses are blocked now, right? I'm not sure about 3. Last time when I asked, it was 3. So now probably, it might be increased. Okay, that's what. So this is how the IP addresses are managed. Okay, so that's all from my side. Let us stop this presentation